Hey everybody, today we're going to do tangent and reciprocal values. Now we're actually going to go through the tangent twice. Not to be annoying, just for extra practice. So if you have this unit circle, get it out. If you don't, you don't need it. Just draw a circle somewhere. I made the boxes so we can practice the radians. And then, of course, we're also going to put just the tangents on here. We're not going to even think about sine or cosine. We're going to just go straight to tangent. So for those of you that like to do division for your tangent, I'd like to see you stop doing that and just get right to the answer because it takes too long. So we know, and again, I'm going to start here. All right, so we're starting over here. I know you can't see me. So this is 0 or 2 pi. I'm going to start with the radian. So we know it's 0, but as we come up from the bottom, of course, we call that 2 pi once we make a complete revolution. If you want to do the pi, let's do the pi over 2. So that's 0 pi over 2, straight up, 1 pi over 2. Of course, this side is pi, so that's 2 pi over 2, straight down, 3 pi over 2. Let's do the pi over 4s next. So we have 0, again we always start here, then right in the middle, 1 pi over 4, straight up, this is 2 pi over 4, which reduces. In the middle here we have 3 pi over 4, this is of course 4 pi over 4, in the middle here we have 5 pi over 4, 6 pi over 4 is straight down, which we already have, and then in the middle here we have 7 pi over 4. Just trying to force you to become a little bit more fluent with this, a little bit more familiar. Now we know that the pi over 6s are close to the x-axis, right? X-axis, pi over 6 is closest to the x-axis, if that helps you. Try not to, with these, go all the way around. Now let me show you maybe a little bit better way than all that reducing. All that reducing is annoying at times. So if we just go right to this, and instead of calling it 1 pi, we'll call it 6 pi over 6. Well, 1 less than that is 5 pi over 6. 1 more than that is 7 pi over 6. Of course, then when we jump over here, we double it and make this 12 pi over 6. And when we take 1 away, this is 11 pi over 6. It's a little bit faster. So the ones with 6's, because that has an x in it, is closest to the x-axis. And then the ones that are a little taller, these are your pi over 3's. So this is 1 pi over 3. And again, my trick, not really a trick, just working with the numbers. Let's call this 3 pi over 3. When we take 1 away, it's 2 pi over 3. Go back to 3 pi over 3, 1 more. This is 4 pi over 3. If we double 3 pi over 3, we make this 6 pi over 3. And when we take 1 away from that, this is 5 pi over 3. Oh, and I forgot the pi over 6. I put it out there, but not inside my square. Okay. That, just a review. Tangent. Oh, I can't erase these. Let's do the tangents. Tangent is slope. It's lots of other things, but it is slope, right? We know that it's sine over cosine. We know that that is also y over x, but all that division takes way too long. So let's think of it as slopes. So when we have a line like this, it's flat, slope is 0, tangent 0. When you have a line that's straight up and down like this, it's too steep to measure. This is just straight from Algebra 1. This is undefined. Undefined. Right through the middle, we know that the side lengths are the same. So if we think of your 45, 45, 90, all right, these are both 4s, or they're both 5. So it's like 4 or 4, 5 or 5. So this is a 1. When you think about going in this direction, these are downhill. So in this direction, this would be a -1. And so this is also a -1. This one's a positive 1. Now we have 2 more numbers. We have radical 3 and radical 3 over 3. Steeper slope is the bigger slope. Steeper slope, bigger slope. So we know, again, I can't get rid of that. We know that radical 3 is a bigger number. So this is your radical 3. So this means this is radical 3 over 3. I have even another trick. Nothing but tricks. So this has 1 3 in it. So does the tangent. 6. 6 is really 2 3s. Oh, look. The tangent has 2 3s in the answer. So anything with a 3 in the bottom, your tangent's going to be radical 3. Then you just have to determine, is it positive or negative? All right, so we know that the ones running uphill are positive, so this would be a radical 3. The ones running downhill are negative. So then the pi over 6s. The ones going uphill, radical 3 over 3. The ones going downhill, negative radical 3 over 3. Much faster and easier than trying to do all this other stuff with the division and fractions and all that stuff. So we are going to do the reciprocal functions. That's our main focus here. But real quick, let's run back through these tangents. All right, so I took off, and you can see where I took it all off. I took off all the unit circle stuff. So we know that tangent is, and I don't even really want to do this, but we know that tangent is y over x. I'd really rather not have you do it. Sine over cosine. I have all, all of these things up here, but I'd really rather not do it like that. So we know that when you go straight up and down, this is really here. This one's undefined. Right? It's too steep. Tangent is 0, flat line, slope is 0. Pi over 4, we know the tangent's 1. And then we know when we have a 3 on the bottom, it's radical 3. When there's a 6 on the bottom, it's radical 3 over 3. And it is that simple. Some other weird things about this. These two, they're actually reciprocals of each other. So if I take radical 3 and I make the reciprocal, I get 1 over radical 3. Then if you fix it, you get radical 3 over 3. So even when we do the reciprocals, there's no new values. And undefined is 1 over 0. So when we do the reciprocal, guess what? You get 0 over 1. So these two are also reciprocals of each other. And you know what isn't a reciprocal of anything? 1, because it is a reciprocal of itself. So when we think about cotangent or the reciprocal function of tangent, the answers are all still there. So it's going to sound weird to hear. Don't learn anything new. I don't know what's happening. Just use what you have. Just use what you know. I'm not trying to learn anything new. At least not right now. Not today. So if I'm going to do cotangent, I'm not going to think cotangent. I'm going to think tangent. So if I'm doing tangent, all right, so here I'm thinking, okay, pi over 2. So I know that the tangent is undefined. Oh, the reciprocal of undefined is 0. So the cotangent, I know that the tangent is 0. Reciprocal of that, undefined. Reciprocal of 1, 1. Now I know here that the tangent is radical 3 over 3 for pi over 6. What's the reciprocal of that? Which means this one is radical 3 over 3. I would not suggest trying to learn anything. Just use what you know and do the reciprocals. Now that brings us to the last two functions, which, by the way, you already know because you can already do all of this. So let's real quick go through the first quadrant. How do you know the first quadrant? Do you know the 1, 2, 3, 3, 2, 1? Do you know the hand trick? Whatever you know, you know. So let's go back through. I'm going to go back through the 1, 2, 3, 3, 2, 1 trick for those of you that maybe never saw it. And I'm a little bit out of alignment, but that's okay. So we know that this is the point 1, 0, and we know that this is the point 0, 1. All right, so then the 1, 2, 3 trick. If you start on the right side, you go up 1, 2, 3, and you come back down 1, 2, 3. Every single denominator is a 2. and every single numerator has a square root sign around it. But we already know the square root of 1 is 1, so we don't really need to put that around there. So there, let's do the whole first quadrant, and all I know is 1, 2, 3, 1, 2, 3. So some things about secant. Sine, cosine, tangent. This is hard to remember. You've learned cosine as the second one. Oh, look, secant, second. Tangent, you're probably not going to mess that up because that's cotangent, which means that the sine is the reciprocal as the cosecant. Remember, these are not equals, these are reciprocals. So the secant is the reciprocal of the cosine, which is the same thing as saying 1 over x, if you'd rather think of it that way. So let's look at our x values and just take the reciprocal. So from this unit circle, from the very first, the only unit circle I only know the first quadrant, I could be able to do the rest of these. So the secant of pi over 2, I'm looking at the x value. So now I have 1 over 0. Oh, okay, undefined. I'm doing the reciprocal of the x value, okay, 2. I'm going to do the reciprocal of radical 2 over 2, which is going to be 2 over radical 2. Ooh, I can't have that. So it's just radical 2. Now, you should know this because we just did this. What is the reciprocal of radical 3 over 3? The reciprocal is radical 3. So what is the reciprocal of radical 2 over 2? The reciprocal is radical 2. It's the same pattern, just different number underneath there, which means we get to this one. And this one is really the nastiest one we have because there's no shortcut to it. 2 over radical 3, the numbers don't match, so I'm going to have to do this. So I get 2 radical 3 over 3. That's the only real ugly one. And then the reciprocal of this x value is a 1. Again, I'm just looking at the parts that I know, which is the unit circle. I'm not trying to do anything new or extra. So cosecant, this is 1 over the sine, which is the same thing as 1 over y, or reciprocal of the y value. So again, let's go back through. This is 1, 0. Oops, sorry, this is 0, 1, and that's 1, 0. It's already on there. And then let's put on our unit circle again. 1, 2, 3, 1, 2, 3. Square roots on the tops except for the 1. And now let's do the reciprocal of the y. So the reciprocal of 1 is 1. The reciprocal of radical 3 over 2 is 2 over radical 3. Got to fix this. 2 radical 3 over 3. That might be the only one that ever slows you down, or should. The reciprocal, where you know this, is radical 2. The reciprocal 1/2 is 2. And of course, the reciprocal of 0, 1 over 0, is undefined. There you have it. It's not any different than the first quadrant of the unit circle. And then after that, we would figure out what location it's in, what quadrant, and that would tell you the positive or negative sign. Now I'm going to use this space down here to do one more thing. What do you do when you can't make a right triangle? Our point is 2, 0. And we want to find all 6 trig functions. This is when knowing this stuff is going to be helpful. Sine goes with what letter? Cosine goes with what letter? Tangent. Sine, of course, because we learn this we learn it in that order, and then that's the backwards from the unit circle, right? Because the unit circle, every point goes cosine, sine. So sine is technically y over r, which is opposite over hypotenuse. Cosine is x over r, and tangent, of course, is y over x. Now, on the unit circle, we can take some shortcuts because we know that the radius is 1. But here, we don't know. This is not unit circle. It's a 0.20. That's not a point on the unit circle, so this is different. All right, so let's break down this point right here. That tells you that x equals 2, y equals 0, and think about what that circle is. If I have the point 20 on my circle, what's the radius? Oh, well, the radius is 2. All right, so here we go. Sine theta is going to be y over r, so 0 over 2, 0. Cosine theta, x over r, 2 over 2, so 1. Tangent is going to be y over x, 0 over 2, which is 0. Now, it's easy to do the others because I'm just going to do the reciprocal. So remember, secant is secant, cotangent is the reciprocal of the tangent, which means secant is the reciprocal of the sine. Reciprocal of 0, undefined. I'm looking at these. Reciprocal of 1 and reciprocal of 0, undefined. So that's how you can do these when you don't have a right triangle and you can't figure out what the hypotenuse is because there isn't one. It's just a little segment, right? So that's the trick to those. That's not on the unit circle, so don't think these are unit circle values. They are not. These are fractions that we've simplified.